So in this lecture, we'll cover the new topic of permutations. So I guess you have been waiting for this now. And let me first define what permutation is, and I'll explain it through an example. So permutations are the arrangements of n objects taken r at a time in a certain order. So the key points is that you should have n objects and you take them r at a time, and the arrangements are in a certain order. So let me explain it using an example which will be easier. So the question is, find the number of three-digit numbers that can be formed using the digits 1, 2, 3, and 4 without repetition of digits. So this is a problem you can solve using fundamental principle of counting, but I just wanted to look at it in terms of permutations, the top. So here we have to find the number of three-digit numbers that can be formed using the digits 1, 2, 3, and 4 without the repetition of digits. So the three-digit number, I will just use three boxes to represent the three digits of a three-digit number, and it's the first, second, and third digit of that number. And what are the options we have? 1, 2, 3, and 4, right? So now I'll call these digits which we have to make the three-digit number objects in terms of the terminology I have used here. So each of this digit is a separate object. So we have n objects, so that means here we have 4 objects, right? So n is equal to 4. And using these 4 objects, we have to fill 3 boxes, right? So here it says that arrangements of n objects taken r at a time. So how many objects do you have to take here to make a three-digit number? You have to take 3 out of these 4, right? So r is equal to 3. So all the numbers which are formed, say it is 1, 2, 3, 2, 3, 4, you have 3 digits taken out of these 4 objects, and these define a three-digit number. So therefore 4 objects taken 3 at a time. That's what you are trying to do here. And each number you will form, like all the arrangements which I am writing down here, is a separate arrangement of objects in order. That is same as a permutation. So each of these is a permutation: 1, 2, 3, 2, 3, 4, 1, 2, 4, and so on. So all of these are separate permutations because you have a different arrangement. So the arrangement in order is different. So 1, 2, 3, and so if we have, say, 1, 2, 4 and 4, 2, 1, so the objects used are same, but the order in which they appear are different, right? So you have 1, 2, and 4, and here you have 4, 2, and 1. So the arrangement of these digits is different. So all the arrangements which we get are separate permutations. So each one is a separate permutation. So how many separate arrangements can you get? This is something which you had done using fundamental principle of counting, and for the first digit you have 4 options, and then for the second digit you had 3, and for the third you had 2 options, and so you had total numbers, 3-digit numbers, is equal to 4 into 3 into 2, that is equal to 24. So you have 24 different permutations. So to understand permutations further in detail, we'll have to explain the different cases that arise in permutation. So the different cases that arise are: 1. Objects are distinct or not distinct. So that will have an impact. For example, if I have to make 3-letter words from ROSE, so these 4 alphabets or objects, you have 4 distinct objects, right? And if I have to make 3-letter words from A, P, P, L, E, the letters contained in apple, you don't have distinct objects. You have 3 distinct and 2 identical objects. So these two are basically separate cases. So we have to deal with these 2 cases separately, and I will actually cover these cases in detail with examples in the next few lectures. So the second case which arises is objects can be used without repetition or with repetition. For example, a simple thing again, where we had make 3-letter words from ROSE. So if we do without repetition, what will that mean? That in a 3-letter word, you can only use each of these objects once. So you can only have a word like ROS or SEO. This is fine, but a word like SSE is not fine, because each object here, like S, is used twice. So that is without repetition. But if you are allowed to use objects with repetition, then all the possibilities are fine. ROS, SEO, SSE, SSS, and everything. So all these possibilities are okay, because you can use the objects with repetition. So therefore it's important to understand these 2 cases, and when we cover the topic of permutations in detail, division into these cases will be helpful for you to solve each problem separately. Identify which case the problem falls in, and then solve that problem accordingly.